All right, boys are back in town. Boys are back in town. Okay, finishing this off. Now we're looking at our graphing kind of section of our test and being able to identify parts of a graph, basically, right? So you can put this into Desmos if you want to, and see where the vertex is. But really clear, and your TI-84 if you want to, 83, 84. But clearly you can see it, it's right here and right here. How easy is that? So just remember that x minus 4 with the plus 3, so that the number on the outside is regular, right? It's just the y value, so 3. So it's going to be the coordinate 3 with the comma there. But then this is opposite, right? Whatever's inside the radical or the absolute value, it's opposite, so not a negative 4, but a positive 4. So it's going to be over 4, right 4 up 3, right 4 up 3. And so when we go ahead and graph this, when it says on the graph opens, you're looking just for the word up, right? If we would have had a negative x minus 4 plus 3, then it would have been going downward, right? Down. But since this is, there's no negative there, it's just a positive equation, it'll go up. So you're going to go right 1, 2, 3, 4, and then up 3. That's our vertex, right? Our vertex is 4, 3. And then it's just going to go upwards. And again, you can use Desmos or your graphing calculator to see that. So we'll show you that right now, just uploading that other video. Here we go. We'll just type in Desmos real quick. Desmos, where are you? Brother, sister. So there's Desmos. And so again, you'd go ahead and type in y equals, here's the absolute value sign, of x minus 4. Uh-oh, did I mess up already? Minus 4. No, we got it. Yeah, right 4. Right 4. We got it. So we're going to go x minus 4, close the absolute value, and then plus 3. This is plus 3, right? Yeah, plus 3. Nice. So then there it is. There it is. There's your vertex, right? 4, 3. And it's opening upwards, going upwards. So that's what we mean when we say open what? And you're like, oh, it's opening upwards. It's going upwards. Opens up. Upwards, but just put up. Okay, nice. There we go. So just showing you how to do that on Desmos. But the other ones are pretty easy, pretty not too bad, pretty not too bad. Okay, the function of this guy has a vertex where? Still looking at here for the x value and here for the y value, okay? But just remember that the x value is opposite what you think. And then the y is not opposite, the y is what you see. So not opposite, it's just what you see. Does that make sense? Okay, so our x value won't be 1, it'll be a negative 1. But then our y value will be a negative 5. So negative 1, negative 5 is where that vertex is. And because of the negative, it's going to go ahead and open downward, right? Open down. Open downwards, just put down. Opens down. Opens up, opens down. Nice. Okay, next one. Ooh, the leftmost point of this function. So that's just basically saying, it took me a little bit to figure that out. What is this asking? So it's the starting point, right? It's the starting point of our radical graph. So this is a radical graph. And so the plus 5 means opposite what you think. So opposite what you think, it's actually left 5. Opposite what you think. So we're actually going to go left 1, 2, 3, 4, 5. And then down 3. So that's going to be here. And then it's actually going to go over 1, up 1 is the next point that we're looking for. And then it takes off. So again, that's going to be the coordinate left 5 or negative 5 and then negative 3. That's the leftmost starting point, x value and y value. And the next point to the right is this point right here. And so that point right there, just kind of do some little bit of adding in your head. So this is going to shift over to -4, right, for the x value. And it's going to go from -3 up to -2 for the -2 for the y value. So this point right here will be -4, -2. This point right there. It's the next point. It's the next point to the right. Next point to the right. So we're going to do -4 because we go to the right towards 0. And then we go up. That's part of our graph. So -4, -2. If you have Desmos, we'll do the next one with Desmos. So we have square root of x minus 2 plus 4. So we'll go ahead and type that in there to show you how to do it with Desmos. So now we're actually going to do y equals the square root now. So y equals the square root of, I already forgot. Is it x minus 4 or plus 4? X minus 2, then plus 4. So x minus 2, oh, nope. It's got to stay in the radical, buddy. X minus 2, which means good. It means right 2. And then arrow, and then up 4. So there it is. Let's double check. Yep, X, that's the next one that we're looking at now. Nice. Okay, so we're going to go right 2 up 4. Cool. So then this is the point 2, 4, right? Opposite, so 2, and then regular old 4. And then we want the very next most right point. So because, ooh, that's interesting. I thought it'd be over 1 up 1. But it's actually going to be, the next rightmost point is going to be 3, 5. That's interesting. I wonder why. It doesn't have a slope or anything. That's so weird. X minus 2 plus 4. Anyways, so 3, 5, it looks like just from our graph. Good thing we did the graph there. I thought it'd be 3. Oh, yeah, over 3 up 1 more is 5. Yeah, that's right. Okay, so we'll go 2, 4, and then the next point to the right, that's right, is 3, 5. Because -2, so right 2 would be right 1 more, right 3, and then 4 would go up to 5. Okay, cool. This function has a point of inflection. When we're saying point of inflection, because we're talking about a cube root, remember the cube roots are like a snake, and so cube roots actually boop, boop, boop. So cube roots have that, and so you could call that like an point of inflection, right? Because you can kind of see, I don't know, how it mimics. This kind of comes down to there. So we're kind of calling that a point of inflection. So we're just looking for the point of inflection is the middle point. So we're just looking for this one. Okay? And that just has to do with the shifting again with that and that. So that's not right 1. It's a positive 1. You think right 1, but it's opposite. It's left 1 and then down 5. And the next point to the right would be let's look at that graph. So we're going to say back 1, down 1, 2, 3, 4, 5 is actually where our graph is, because this was actually 0, 0. Sorry. So our graph is actually here, and so to go over 1 and up 1 would be here. And that's 1, 2, 3, 4. -4 for the y value, 0 for the x value. So that's going to be, right, because this is the whole graph going like this, do. And so that's the very next point to the right. So we'll put in a 0 and a -4. Over 1, up 1. Nice, there we go. Over 1, up 1. Okay, so the next one has a middle inflection point of right 2 is where our middle point is. So right 2, so that's just a positive 2 and then a regular positive 1. And then the next point to the right is, well, if it's starting here at 0, 0 and it's going right 2 and up 1, then the next point would be 3 and up to 2. And then it goes like that. So it's that point is the point to the right. And so that would be over 3 up 2. You're basically just adding 1 to that, adding 1 to that. Can you see that? You're just adding 1 to your middle point. Okay, please describe the movement of the parent function. Remember, it's opposite what you think for inside the absolute value, opposite. So that is actually going to be opposite. So that's actually going to be a right 4. There it is. Whoop, there it is. Number 29 is going to be a left 5 and then a down 2. Yeah? Left 5, down 2. There it is. Whoop, there it is. Okay, last one here. So then please go ahead and move the parent function. So that's going to be opposite what you think. You think left 6, but it's actually right 6. And then down 1. It's good to practice these. These will be on the test. So right 6 down 1 will be that first one right there. Last but not least, matching. Okay, so then we're just going to basically match each of these equations. I really like this one because this one reminds me of right 3. And you can even write all the transformations down on your paper if you want to. So this one is left 2, right? Left 2. This one is right 1. It is a cube root on that one. Right 1, but it is a cube root. Don't forget the cube roots look a little bit differently. And then these ones are just square roots. So these ones go like this one go like this this one go like this. Misa, out of here. Not Jar Jar. Okay, this one's just an up 2. And this one's just an up 2. And this one's just a down 2. These are all radicals down here. So that's a down 1 rather. Ooh, this one's a left 2, and then an up 2. Okay, so we're just looking for each of those transformations. So let's try to find the cube root with the left 2. So cube root with a, here it is, cube root with a left 2. So that one, so number 1 is going to be D. Number 2 is a right 3, but it is going to be a radical there. So here's a radical equation, right 3. And so that one's going to be A. The next one is the other cube root, which is a right shift 1, which is right here, right shift 1. So that one's going to be C. And then the, let's do this one while we're up here still. So I think this one is going to be an up 2, but it's also going to be a left 2. Right, the left 2. So that's going to be B. That's going to be number 6. And then looking at these two graphs, negative. There's a negative. It's supposed to be here. So there's a negative in front of the radical there, negative. And so that means that it's actually going to be upside down. And then a shift up 2. And here is your shift up 2 and then upside down. So that one's going to be E. And then finally, last but not least, number 5 is going to be a shift down 1. So original parent function was here. And it's shifted down 1. And so that is going to be F. Okay, thanks for watching. Hope this helped you fast forward through and able to check all your answers. Email me if you have any other questions. We're still trying to work on Canvas. We make mistakes, so email us for fixing those. Extra credit. Thanks for watching. You're going to ace this test. Thanks for watching. Thanks for watching. Bye for now.